I want to do some examples from chapter 16. This is combining random means and variances of random variables. So hopefully you have this copy of the notes to help you out a little bit. So consider a small ferry that can accommodate cars and buses. The toll for cars is $3 and the toll for buses is $10. Let X and Y denote the number of cars and buses, respectively, carried on a single trip. Suppose that X and Y are independent and have the probability distributions shown below. So you've been doing problems like this. So X is representing the number of cars, which means you might have 0 cars all the way up to 5 cars on the ferry. And for buses, you might have 0 buses, 1 or 2 buses, and then those are the associated probabilities. So before we do some calculations with that, I want to talk about a little bit of vocabulary. What we deal with and when we refer to statistics is a lot of times we're working with samples. So we talk about a sample mean, and the symbol we use for that is x bar. We talk about a sample standard deviation, and we use S sub x for that. Or the sample variance, which we use S sub x, quantity, that value squared would be the variance. What we use these statistics for is we use x bar to estimate the true mean. This is the Greek symbol mu, the Greek letter mu. So mu sub x represents the population mean. So for example, maybe I want to know what the mean height of all 16-year-old girls in the United States is. That's a population mean, and I don't know what that is, and there's no way I could find out all the heights of all the girls and calculate the average. But what I can do is I can draw a sample and I can calculate the mean of my sample. That's x bar. And then I can use that if I've drawn a good sample, and we've talked about sampling strategies, then I can use that to estimate my population mean, mu sub x. So this is a Greek letter sigma. And so this is sigma sub x and sigma square sub x to represent the standard deviation and the variance. So we use statistics to estimate unknown parameters. So that's like a pretty big deal with statistics. So what we're going to do first is compute the mean and the variance of x. You already know how to do that, so let me just kind of remind you of that. So you're going to take your chart values, you're going to put all of the values of x in L1, and then all the probabilities, remember, in L2. Then if I do stat calc one variable stats, and I already have that set up with L1 and L2, and we get our mean is 2.8. So I get, and I'm going to treat this as the population because we're told that that's what they all are for this. If you look back at the problem, it says that that x and y are independent and have the probability distribution shown. So this is for all value, or for all the values of, all the ferry. Okay, I'm not saying that very well. Anyway, we're going to use this one. Mu sub x equals 2.8. We're assuming this is true for all cars and buses on the ferry. There, I could have said that. And then now notice that we don't, if you look at, we have sigma sub x, but we want the variance. So to get sigma sub x squared, if I want the variance, I'm just going to have to take the I'll do 1.2884 approximately and square that. And I already did, and we get 1.66 about. So now this represents represents the number of cars. Now obviously you can't have 2.8 cars on the ferry, but this is in the long run on average how many, that would be the average amount of cars on each trip on the ferry. So then you can do the same thing. You can pause the video and then do the same thing for the mean and the variance of y, which would be the buses. So you should get mu sub y equals 0.7 and sigma sub y squared. Remember, you're going to square the standard deviation value, and we get about 0.61. Okay, so that part I went through quick because you know that part, other than my stumbling because I couldn't speak. All right, so On this next page, you've got some formulas. So means and variances of random variables, if A and B are constants. Now, might look at these and go, I don't know what these formulas are. Well, I'm going to go through and show you with some examples. So if we have mu sub x plus 1, mu sub x plus a, that's just equal to mu sub x plus, and then an a. All right, so notice here it's part of the subscript. Here it's not. If we have mu sub b times x, then we end up having b times mu sub x. If we have mu of bx plus a, we get b times mu sub x plus a. So these are formulas that we can use for the mean when we are combining random variables. Now you watched a little bit of this on AP Classroom. So for the variance, notice this one, if you have sigma squared x plus a, it's just equal to sigma squared x. So adding something doesn't change the variance, and we'll talk about that a little bit. Sigma squared of bx equals b squared times sigma squared of x. So you can see these formulas here. And then notice this last one, sigma squared of bx plus a equals b squared sigma squared of x. But notice the a is not there. It's the same reason it wasn't up here. So I'm going to show you some examples, and you'll see, hopefully, what I mean by there with those formulas. So you'll want to keep those formulas handy so you can look back at those. All right, so compute the mean and variance of the total amount of money collected in tolls from cars. Now, if you look back at the problem, we're going to collect $3 per car. So we want to know, what is mu sub 3x? Well, the formula, if you look back, mu sub 3x would be 3 times mu sub x. So that's how we use the formula. So we have 3 times 2.8. So we get $8.40. All right, next we want sigma squared of 3x. So if you look back at the formula, you see we're going to do, over here, we're going to take b squared times sigma squared of x. So that's going to be 3 squared times sigma squared x. So we get 9 times 1.66, which is about $14.94. Okay, so that's how you could use the formulas for that situation. Then in part D, compute the mean and variance of the total amount of money collected in tolls from the buses. So go ahead and pause this and give it a try. Okay, so it's $10 per bus. So when you take mu sub 10y, 10 times mu sub y, we end up with $7. You have to look back and see what mu sub y was and sigma squared sub y. And for the variance, we get $61. Now, if we had wanted the standard deviation, you just take the square root of the variance, and that's the standard deviation. All right, so what if we actually, instead of treating them separately, we actually want to see what happens when we combine two random variables. So what happens to those means and variances when we do that? So here's a formula that you're going to need, some formulas. If z equals x plus y, then mu sub z equals mu sub x plus y, and it's just mu sub x plus mu sub y. Same thing true for subtraction. So in words here, that just means the means for random variables can be added or subtracted, just like you might expect. No big deal for those. However, variances. To combine variances x and y have to be independent. So that is a must. The variables have to be independent, or else we would not be able to use these formulas. So sigma squared sub x plus y equals sigma squared x plus sigma squared y, as long as the variables x and y are independent. Over here for subtraction, if we're subtracting the two values, sigma squared x minus y, the combined variance is sigma squared x plus sigma squared y. That's not a typo. You always add. The idea is whenever you are combining two variables, whether you're adding or subtracting, you're always going to create more variance when you are combining two variables that each have their own variance. Keep in mind that standard deviations don't add. So you can't make this statement like you can with means. Standard deviations don't add. Variances do. So if you're given the standard deviation, you're going to have to find the variance first when you combine them. And so if you wanted the standard deviation, you have to find, the combined variance first, and then you square root it. All right, so those are not the same thing. And if you think they are, then you kill a puppy, because that's kind of the same idea on that. All right, so the next thing we're going to use those formulas now for, compute the mean and variance of Z equal the total number of vehicles, cars and buses, on the ferry. So starting with the mean, we want mu sub Z, which is mu sub x plus y, which the formula for that, we can just add those, mu sub x plus mu sub y. So we get 2.8 if you look back and see what the values we had, and 0.7 was for the average, the mean for buses. So we get a total of 3.5, and this we'll call vehicles since we have cars and buses. So on average, it would be 3.5 vehicles on the ferry. To get the variance, sigma squared Z is equal to sigma squared X plus sigma squared Y. I guess I could have had an intermediate step right there. I should have. And I can add these because if you look back at the original problem, we were told that the cars and the buses on the ferry were independent. So we have 1.66 plus 0.61, and we get 2.27, and that would be vehicles. And that is our variance. So then the next one, compute the mean and variance of W, which is the total number, or amount would be better, of money collected in tolls. So I'm going to define W as 3 times X, because $3 for each car, plus $10 for each bus. So that's what we're looking at. So we have mu sub W equals mu sub 3X plus 10Y equals mu sub 3X plus mu sub 10Y equals 3 times mu sub X, I'm just applying the formulas, plus 10 times mu sub Y. We already did this, so rather than compute this again, you can look back up to see what it was. It was $8.40 plus, and this one, if you look that back up, you can see that was $7. So we get a total of $15.40. For our standard deviation, we're going to have sigma squared 3x plus sigma squared 10y. So we already calculated this. So we're going to have $14.94 plus 61, because we already calculated that. You can check back a few slides to see that. So we get $75.94. Now, one thing you haven't seen yet, I haven't shown you an example yet where we have to deal with this idea of this subtraction on that. So we'll see one coming up here in just a minute. I'm going to do a problem from the textbook. All right, so this is page 383, number 24, and these are the directions, and this has no context. This is practice with formulas. So given independent random variables with means and standard deviations as shown, find the mean and standard deviation of each of these variables. So they first say x minus 20. Well, what that means is we have to find mu sub x minus 20, and then we have to find the standard deviation, so sigma sub x minus 20. So to find the first one, we're going to use the formula, and we're just going to take mu sub x minus 20. So mu sub x is 80, because that's the mean of x. So we get 80 minus 20, which is 60. So that's the first answer. To calculate sigma sub x minus 20, remember if you look back at the formula, let me see if I can pick the right slide. If you are doing sigma of x minus that, or x plus a, and it wouldn't matter if it was x minus. Remember that the adding or subtracting doesn't change the spread, so it doesn't change the standard deviation. So we're just going to have sigma sub x. So we get 12, because that's the standard deviation for x. Then on the next problem, we want mu sub 0.5 times y. So it's just 0.5 times mu sub y. So we get 0.5 times mu sub y is 12, the mean of y. So we get 6. And to get sigma for that, we're going to just take 0.5, because this does, when you multiply, it does change the spread. And you should have seen that on the videos that you guys watched. So times sigma sub y. So we get 0.5 times 3, which is 1.5. Mu sub x plus y is mu sub x plus mu sub y. So mu sub x is 80, and mu sub y is 12. So we get 92. And then the next one, sigma sub x plus y. Well, remember that variances or standard deviations don't add. Variances do. So on a problem like this, we have to go to the variance. So we have to figure out sigma squared x plus y. And because we were told they're independent, we can add the variances. So we got to square these. So we're going to take 12 squared plus 3 squared. And we get 140, well, I knew that. 144 plus 9. So we get 153. So now I can go back to this and say the square root of 153. And I want to know about what that's equal to. So it's about 12.369. But you're going to have to find this first, and then you can find the standard deviation. All right, so mu sub x minus y. We're just going to take mu sub x minus mu sub y. So we get 80 minus 12, because that's the mean of y, and we get 68. However, this one, we can't find the standard deviation. We have to find we have to find the variance of x minus y, and that's equal to the variance of x plus the variance of y. Because remember that we don't ever subtract them, we always add them. So we're going to end up with the same answer that we had. I'm not going to recalculate because we just did, we just calculated that that was 153. So this is going to be 153. So we're still going to get the square root of 153, which is about 12.369. So whether you are adding or subtracting, you're going to get the same variance and the same standard deviation. On part E, now all this means is we're taking like the variable, these are subscripts to just denote that you've got a variable coming from this y and then another one. So mu sub y1 plus mu sub y2 is what you would calculate. Well, that's just going to be 12 plus 12, and we get 24. Then for the variances, again, the standard deviations don't add, variances do. So we're going to have to find this. So we get the variance. So we're going to have to square this. So it was a 3. So we're going to have 3 squared plus 3 squared. 9 plus 9 is 18. So my standard deviation is the square root of 18, which is about 4.243. Okay, and then on the last one, to get mu sub 2y, we're going to have 2 times mu sub y, just using one of the formulas. So that means we're going to have 2 times 12, and we get 24. Notice it's the same thing that we got up here. And then for the standard deviation, we can take 2 times sigma sub y. We get 2 times 3, which is 6. Whoops. And notice it's not the same thing as the standard deviation we got up here. And we're going to talk about that, the idea of varying together or varying separately. And we'll have some other examples that have some word problems that kind of go along with it that will maybe make more sense in that situation. But I just wanted to show you how you could use those formulas and put those formulas into your hands so that you would have a copy of those to help you with the problems you're going to have to do.